K-Wave 6 Radio and our host Kirk Spencer welcome you to our show bringing positive messages to today's world. And now, here's Kirk.
Good morning and welcome to K-Wave 6 Radio. I have a returning guest who happens to be a favorite of mine. He's been here before, but the thing that I really want to say is the first time I actually heard his videos, was listening to his videos, I was impressed that I could get a lot of information within 5 to 6 minutes, or sometimes 3 to 6 minutes. And he has a voice that's just, for me, it's just, I'm talking to a friend of mine, or listening to a friend. So even when we got on to do this call today, it was just kind of strange because I hear him 6-7 days a week, and then it's just I'm talking to him and I'm hearing his voice come back. So we're going to talk about Ben Davidson. Welcome back to the show.
Absolutely, thank you. Good morning as well.
Good morning. And he's from Suspicious Observers, and he has been on a, 2 or 3 month trip now? How long has it been?
We started in the middle of June, so July, August, September, October. We are right about at 4 months. Right, tomorrow it will be 4 months actually.
There you go. For 4 months, he has been from Ohio, where he's from, to Canada twice. I've been following him all the way to the West Coast, and now he's back on the East Coast in Virginia.
Absolutely. We'll be everything for a couple days more.
There you go. So tell us, how's the trip been going?
The trip is going very well. It is a lot of fun. It's also very exhausting, especially when I keep up the 6 to 6:30 a.m. release time for the daily news, even when I'm on West Coast time, and so that means that to get it out by 6:30 a.m. Eastern time, I was wake up just a little bit after midnight when we were on the West Coast, so I could try to get it out by 3 or 3:30 a.m. local. But we managed to work around that. I quite clearly survived, and it's very good to be back on Eastern time now.
I have a question for you about that trip. I was listening to the show and just remember at one point, at least one recording, I remember you saying, it's 6:30 a.m. Eastern, 3:30 Western, something like that, and it's just like, okay. But with all that traveling and being in different time zones, and you're still trying to get your show, and you actually did it very successfully, except for what was one time when you didn't have Wi-Fi up in Canada, I think it was, early on in the trip.
Right.
You guys have been faithfully getting that show out every morning, but are you the one who's doing all the driving and all the research, or is Kat involved with that as well?
Well, if I just explain that I do all the driving and I do all the research, it sounds like she doesn't do much. But in reality, she does all the navigation. She does almost all of the cooking. She is our electrician. She is our plumber. She is our mechanic. And she's also our, very aesthetically pleasing housekeeper. So she does an unbelievably large amount of stuff around here, including helping take care of the dogs, our 2 little Yorkies on the trip, which we pretty much share duties for that as well. But she pretty much holds everything together. She helps me keep my sanity, and But when it comes to the driving and the research, that's on my shoulders.
Yeah, I hear you. Well, I know she does a lot of your, put it this way, from my perspective, she does most of the email responses and whatnot.
She does a ton of email responses. She also runs the actual website for the tour, which is observatoryproject.com. And, she's keeping up with the blog. She's keeping up with all the changes to the schedule, which, seems to change every couple of days. And she responds to most of the emails that come into that website, I should say.
Yeah. So that was cool. I was just kind of curious more about the driving part. It was kind of like, man, you're getting up early, you're driving, you're doing the research. It's like, how do you guys actually work that out? I was more interested in the traveling aspects, but yeah, I know that she would be, well, from previous conversations, you were telling me that she was doing the website and whatnot, so I know that. But anyhow.
Absolutely.
So,
Absolutely.
You're in Richmond? No.
We're heading to. We're going to be in Richmond tomorrow, and tonight we are going to make a private stop in King George, George, Virginia. We'll be in Richmond tomorrow.
Okay. So, what else can you tell us about the trip?
I really love showing kids sunspots, and I love showing them what the sun looks like through all our satellite images. It's quite a thing to, pull up HelioViewer or the SDO website and, show the sun and the different wavelengths and the different layers of the atmosphere and the surface in bright pink, blue, green, orange, and just hear 100 kids go, "Wow!" all at the same time. And then, especially because before I get there, a lot of times these kids are made to watch the Sun series videos that I put out, which are aimed at ages 13 and up. But some of these kids are only in 4th grade, and they're watching the Sun series, and they're asking very relevant questions. The kind of level questions I get from grown adults who are very into this stuff on the internet. So it's really encouraging. To see at least some youth in this country going in that direction and taking an interest in science, however small or however short-lived it might be.
Yeah, it's actually great to teach kids. I was a school teacher for many years, and it's very rewarding when the teachers are actually allowed to teach. So you actually have that specialty to be able to walk around, or I should say drive around and go in and talk to kids doing your specialty thing, and you're not too governed by, if you will, the system. I'll just leave it at that. So, what more do you have in mind for your, I guess you're going to stick with the southern states now that it's getting to be colder and more winter.
Yeah, as you mentioned, we started in Ohio, and we shot straight east through Pennsylvania, up through New York, New England, did eastern Canada, came back down Toronto to Buffalo, swung south of the Great Lakes, up through the I-states, then Wisconsin, Minnesota, the Dakotas, Montana, back up into western Canada, came down Vancouver to Seattle. We've hit Washington, Portland. We've hit Washington, Portland, Oregon, and a couple other cities in Oregon, actually. We dipped through Idaho, Wyoming. We'll actually be back in Wyoming near the end of the tour, too. We hit a stop in northern Utah, came through Nebraska, Kansas, Missouri, where we had a wonderful interview with the Joplin Morning News team. And after that, we kind of shot back up, right along the Kentucky border, and now we're after a stop in West Virginia. We are here in Virginia for a couple of days, and in just a couple more days, we're going to hopefully be getting together with Dr. Kong Papaguyen, who has helped us with some of our earthquake theories. We're helping do sort of a public, open source peer review of his, and Electric Universe enthusiast. He's just a terrific guy. And on top of all of that, his day job is at NASA. So he's just a wonderful guy to have on board with a lot of this stuff. But yeah, you're right. As it's about to get colder. We're going to be hitting the southern states next. As we kind of crept across the northern states and Canada, it's time to try to avoid the snow at all costs.
No kidding. Listen, while you're talking about Dr. Yin, tell us a little bit more about his, you're saying theory, because, I'm questioning the word theory because I'm watching your show every day, and I'm seeing the correlation that you guys are bringing up between sunspot activities and earthquake and storm activities here on Earth. Can you explain that more?
Sure. This started with us using coronal holes, a feature on the sun, to predict the ebb and flow of earthquakes, and what we consider the ebb and flow around the magnitude 6 mark. USGS says we should get about 3 magnitude 6 earthquakes every week, but rarely do we see exactly 3 in 1 week. We usually see 1 or none, or we see 5 or 6, or some even larger earthquakes. It turns out you can watch the coronal holes and do that pretty well, but we were looking for a way to get the biggest earthquakes only, and figure out what some of the triggers for those might be. And since there are permanent coronal holes at the north and south pole of the sun, we figured, well, let's take a look at the polar magnetic fields of our star. And went and I got the statistics department from the Ohio State University to draw up the algorithm and what they call a statistical R code for the solar polar field, magnetic fields, and then simply input the earthquake data and found a very, very statistically significant correlation with the largest earthquakes on the planet. And Dr. Uyen, who I had met at the Electric Universe conference back in March, he agreed to hop on the paper with us and try to help us, reveal some of the potential mechanisms that could be involved. I have also been expressing what I call the Earth spots hypothesis, both on YouTube and on the website. The notion that earthly storms are very much like sunspots. They're very much magnetically connected with other systems and other places on the planet, just like the sunspots do on the sun. And that went along pretty nicely with what I'm calling the Uyen system of storm formation and intensity. So basically we're combining my idea that the Earth should have Earth spots just like sunspots, and given how most of what we do is about a connection between the Earth and Sun, including Dr. Uyen's theory was perfect, and his theory basically states that when we get these large solar events, and whether the solar event is a flare actually on the star, when it's a CME or a solar storm impact here at Earth, these things tend to form and intensify tropical storms. And so we've been tracking that every day, and that's going very, very well as well. But something interesting that we weren't really expecting to find is that the most seismically active areas and the ones that produce the largest earthquakes seem to be right in the middle of 2 Earth spots, or 2 big low-pressure systems, or they tend to be right on the path that a tropical storm eventually goes across. This happened with the Iceland volcano. A big low in the Atlantic started taking off right towards it when it began erupting, and then it just sat over top of it for 5 days. This happened a couple of years ago when we had that big earthquake in Virginia in August of 2011. 3 days later, Hurricane Irene ran right over top of it. We've seen this happen in Japan. We've seen it in Philippines, in Mexico, in Hawaii, even in Alaska and Canada. We've seen this as well, and so it sort of began as a blending of our observations, our hypothesis, and then Dr. Uyen's hypothesis, and this is really branching out and having tangents in all kinds of different wonderful and exciting directions. We're very excited about it.
You just said something that just reminded me, because everybody keeps talking about it, showing it on videos and whatnot. You're talking about these earthquakes and whatnot that are going on, and you said Mexico. Of course, this is where I live, but I'm not anywhere near where this event happened. Do you have any information or theories or ideas, whatever, on that that crack in the earth that's up near the border of the U.S. and Mexican border? If you remember what I'm talking about.
Yeah, that made the news maybe a couple of weeks ago. Right. Well, there wasn't any major seismic activity near there. There could be that you can use to blame that on, and so it was really sort of a question of exactly how fast did this form and what was the cause. Now, I don't remember. Perhaps you know this a little bit better. Is that a heavily populated area where that crack is, or is it kind of out in the middle of the desert?
Out in the middle of nowhere.
Yeah, so there's a good chance it could have been there for a while, or it formed slowly over time. it is indicative of there being just significant changes that sometimes fast and sometimes slowly pull this Earth apart and push it back together and change elevation, and it's just a great symbol of our active Earth.
Yeah. Well, with that, we're going to take our first break, and stay tuned with us. We'll be right back with Davidson of Suspicious Observers.
Yes, this is Marlo Wright of mbymarlo.com, and you're listening to K-Wave 6 Radio.
Are you ready to put an end to thinking about how you wish it were and take action? Take this step to find out more by going to coachingbyria.com, and you can receive your free consultation session with Coach Ria. Coach Ria is a certified professional life coach with a passion to help make the difference in the world.
Hi, this is Dr. Nick Leroy, and you're listening to K-Wave 6 Radio with its host, Kirk Spencer. I'm a holistic physician. I specialize in women's health, breast thermography, the alternative treatment of cervical dysplasia, and gastrointestinal disorders. And you can find me at drnick.net.
And welcome back. Today my guest is Ben Davidson of Suspicious Observers. I'm just going to actually let Ben run with the show because he's got so much to tell us. But Ben, where do you want to go from here?
Well, I'd like to talk a little bit more about some of the ways that the sun can really come in and affect our planet. Because one of the first questions we get from somebody who just stumbles onto this stuff is, how could the sun affect an earthquake or something like that?
Mm-hmm.
And, the sun is more than just that ball up there that gives us light. We're finding, and these are all things that happened, discoveries that were made, since the latter part of the first decade of the 2000s. So, we're starting around 2007, 2008. And just since that time, which is longer than, most people have been out of school since that time, if you will, we've discovered that there are what NASA calls magnetic portals that directly, magnetically connect Earth to the sun. In fact, most planets have these. We find that they allow these things called flux transfer events to surge charged particles into Earth's magnetosphere and into our electric systems every 8 minutes. We found that the solar wind is quite pervasive throughout the part of outer space in which Earth orbits the sun. It's really not much of a vacuum at all. It's much more of a vacuum than it is standing here on the ground. But there's so much activity. There's dust, there's gases, there's charged particles flying at hundreds of kilometers per second from the sun. And it's really like being in an electric sheet where Earth orbits. Recent studies have suggested that even slight changes in the length of a day, Earth's rotation, are affected by the sun. The actual exact distance from the sun at which Earth orbits varies on the slight degree, and that's based on solar activity. Just in the last 3 years, we have discovered that the sun causes sudden stratospheric warming events. It has major roles to play in all of the long-term cycles in the weather, like the El Nino and La Nina cycle, what's called quasi-biennial oscillation. And we're finding that the sun has these strong effects on pretty much every layer of the atmosphere that we were not taking into effect just a few years earlier. And, in terms of climate change and in terms of trying to predict the temperature, we still do not fully include all of these new factors that we've discovered over the last few years. We just know that that's going to have to change coming up soon if they want to have if they want to start to have any accuracy, because they've been lacking it for about 2 decades. But what's really interesting is the fact that this study of how the sun affects everything from the magnetosphere, the ionosphere, the atmosphere, and even down to the ground, where a big solar storm could send ground currents through transformers and electric power grids and basically throw us back to the Stone Age. We're finding that this realm of study is converging with something that we call pre-earthquake signals. Now, pre-earthquake signals can be anything from animals fleeing a coastline before an earthquake and tsunami to what they call earthquake lights, these rainbow flashes that seem to appear in the atmosphere and ionosphere above earthquake zones before the earthquake occurs. We notice a number of other phenomenon in what's called the global electric circuit and other geomagnetic systems, and especially in the electron content and the ionization of the ionosphere and upper atmosphere directly above earthquake zones. We're finding that these two areas of study are coming together. This is what this is part of what I'm trying to do, or I guess communicate in a big part of the paper that Dr. Wu Yan and I are writing on how the solar polar fields affect earthquakes.
Can I stop you? Can I pause you just for a moment? You're talking about something, and if you don't mind, I'd like for you to elaborate on something that you're talking about right now. And
okay.
I have an understanding of it, but I have a feeling there's, even though I'm still, in comparison to you and Dr. Yu Yan, I'm definitely a novice, but I have a feeling there's people that know less about this than even I do. So explain, if you will, just the magnetic influence of the sun upon the Earth, the electrical influence, because magnetics and electricals actually work together, and then we're talking about fire and the heat and the pressure that comes from that. You talk about this in your videos a lot on a day-to-day basis, but just kind of give us a, if you will, a rudimentary or at least a elementary school level explanation of how that all influences what you're just talking about right now.
Sure. If you've ever played with a magnet, or you've seen what a magnet will do to iron filings, or you've ever seen any kind of visualization of the magnetic fields on a magnet, you've got the little magnet here, and you see the magnetic fields coming out of one pole, wrapping around to the other side of the pole, and this is very much like what happens on the planets and on stars. The sun's got magnetic fields that loop around it, and magnetic fields that stream out into space. And these start at the sun, and they loop all the way out past Pluto. And so very clearly these are interacting with Earth in significant ways. That magnetic portal I described earlier, that's sort of a direct line from Earth's magnetosphere directly across to our star. The polar fields come out of the north and south poles of the sun, but they wrap all the way around and connect back to the other pole. And, those are some of the ones that go out past Pluto, so those probably hit Earth at Earth's polar region. And so there's really almost no way in which we are not magnetically connected to our star. We have, a good way to think of it is polar connections and equatorial connections, equatorial being of the equator, or, basically the exact middle between the poles. Mm-hmm. And so, basically what we did for this analysis is Stanford University has been monitoring the strength of some of these magnetic connections. How strong are these magnetic fields on the sun? And they've been measuring that pretty much consistently since the mid-'70s. And we essentially, and by the way, they do this for the North Pole and the South Pole separately. And so you can tell when one is strong, when one is weak, when they're going through these oscillations back and forth. And they do this. The North Pole is stronger, and then the South Pole is stronger 6 months later. 6 months later, the North Pole is strong again for a total oscillation of about 1 year. And this goes on for about 11 years, and we notice that both poles tend to be really, really strong when there are not a lot of sunspots. And then as the poles come into reverse, as some of your more educated viewers might know on this topic, the sun's poles do reverse every 11 years, and that's when what we call sunspot maximum. A good way to think of it is, if you can really picture either a magnet or even a planet or a star, and the magnetic fields looping out from the polar regions around to the other pole. Well, think about what it would look like when those reverse. All right, well, so you start with the magnetic fields being aligned north and south, and most of them are coming out of the poles. During this time, there are no sunspots normally, or there are many fewer sunspots. Then, as the fields begin to reverse, they leave one pole and go to the other pole, they've obviously got to migrate to lower and lower latitudes, cross the equator, and then get back to the other pole. Well, as that's happening on the sun, the magnetic fields begin to poke through the surface, and we see these sunspots. In fact, we often see the magnetic fields looping out of one sunspot and going back down into another one. And so this is kind of what we're seeing there. And watching it happen with sunspots on the sun is just a smaller version of watching what happens throughout the entire solar system during the cycles of the polar fields, which basically have the same or similar effects all the way out through the planets.
Wonderful. Let me ask you one more thing, because as you're talking, I'm listening and I'm thinking about, you talk a lot about especially recently, you're talking about the coronal holes in the sun. Can you explain that a little bit more?
Absolutely. When you are looking at the sun in certain wavelengths, the ones that I mentioned allow you to see the magnetic fields that connect sunspots to one another. You are likely to see a lot of magnetic fields connecting sunspot to sunspot, and you'll see they kind of look like a loop or an arch that goes from the surface of the sun to another point on the surface of the sun. Then you see some larger loops that arch over, a quarter of the entire sun. And then you see these areas that don't have any loops. And this is where you find the coronal holes. Now, it's not that those areas don't have magnetic fields. It's just that they do not loop back down to the surface of the sun. They extend out into space. And those are what can interact with Earth pretty much instantaneously. Normally with solar flares and with solar storms, when we're worried about the sun taking out the power grids, that's, at least in most times 24 hours between the actual solar flare and the time that the eruption gets to Earth. Mm-hmm. And the coronal holes have similar effects on the solar wind, which usually take 2 to 3 days to get to Earth. But the interesting thing about the earthquakes and the ability for a coronal hole to affect us the moment it faces Earth is its magnetic field lines extend out into space and can interact with our planet. And this is sort of counterintuitive to most people, even those educated in science, but when that happens, time is very much not a factor. The speed of light no longer becomes the cosmic speed limit. And consider that magnetic field connecting the Earth and the sun, just straight together, almost like you and I are holding a rope together, and we're both kind of pulling a little bit so it's taut, it's tight. Mm-hmm. And let's say I wanted to make a wave go across that rope, so I flick my wrist up and down, and you see the little wave, that's made in the rope go from me to you. Mm-hmm. Well, no matter how fast I flick my wrist, let's say I can flick my wrist fast enough to create a wave that's going at the speed of light, it's still going to take some amount of time for it to get from me to you across the rope. However, if we are holding that rope tight, taut, and I yank on the rope, there is no time delay. You feel it instantly on the other side because everything is perfectly connected like that. And so now pretend we're not on the opposite sides of a room. Pretend you're 100 million light years away. You're on the other side of the universe. You're on the other side of the galaxy or something. Well, we know it would take a very long time, even something going at the speed of light, to travel that distance. However, if that rope, if that connection is tight and perfectly connected, I can tug, and 100 million light years away, you will feel it instantaneously. This is known as quantum entanglement or action at a distance. And this is what we're witnessing when we see these coronal holes trigger earthquakes on our planet. It seems counterintuitive to most people who study the sun and space weather because we're used to the solar wind taking days and days to get here. In fact, even when we have a solar flare, from the time it happens on the sun to when we detect the X-ray and extreme ultraviolet radiation, that's still 8 minutes. It goes at the speed of light. And it takes 8 minutes for light to come from the sun to Earth. However, those coronal holes need no time delay because they are magnetically tethered to the planets in 2 different points in outer space, and they can have instant effects. And really, all you need to think of is that rope being held between 2 people, and once you give it a tug, if it's tight along that entire way, it doesn't matter how far away the other side is. The other side feels that tug, I should say, pretty much instantaneously. I don't know if I explained that well enough or if that makes sense, but...
Well, let's put it this way. It made sense to me, and I think I could explain that to a class down here, and I think they would understand it. If somebody else doesn't understand it, that's okay. Ben always has an open door to come back and do a show here, so it's not a problem. Anyhow, we're going to take our second break, and we just ask that you'll stay tuned with us, because we're going to be right back with Ben Davidson of Suspicious Observers.
Hello, this is Andy Peacher from Freedom Talk Radio. You're listening to Kirk Spencer on K-Wave 6 Radio.
Hi, this is Pat Kammer, author of Love's Voice Changes You, Book 1. And I now have Book 2, which is called Hello Awesome, Message from Spirit in Pat's Patters. Buy your book from Amazon.com.
Do you need a website or a webmaster for your business or hobby? A wordsmith for a research paper or for a script, an article, or for a language translator? Do you need an audio or visual project created or edited? Contact K-Wave 6 Productions at www.kwave6productions.tk for all your website, writing, audio, and visual needs. Our rates are competitive and our services are excellent. That's K-Wave 6 Productions at www.kwave6productions.tk or email us at info@kwave6productions.tk.
This is Belinda Farrell from Find Your Friggin' Joy at www.hunahealing.com, and you're listening to K-Wave 6 Radio.
And welcome back. Again, my guest today is Ben Davidson of Suspicious Observers, which you can find on suspiciousobservers.org, is it?
Yes.
.org. And on through his YouTube videos, all you have to do is put in Suspicious Observers, and you can catch up with his daily videos, sometimes twice daily videos. This is something that, well, I just changed my schedule around recently, but it was the first thing I did when I turned on the computer was go straight to YouTube's and check out what's the world going to be like today. And that's where I started my day off, but now I'm getting up before he actually posts them, so it's still on my early list to do. So anyway, with that, we're back with Ben, and I do want to ask Ben some questions here. Then it's just going to let him run. He has so much information, but I have some questions that I just feel that I need to have answers for. So, I think this one will be fairly easy to do. You're talking about 8 minutes to travel from the sun to Earth. Most influences from the sun. Most, not all. Can you explain that with the travel time, as in also... this is probably one of those questions that most people don't ask. It probably kids ask this question. Well, if it's noontime and that's when the sun is the highest in the sky, why is it the hottest around 2 p.m.? Can you explain that, teacher?
Yeah, it happens for the same reason that the coldest time is not midnight, but about 3 or 4 a.m., just before the sunrise. You know, the energy from the sun is pretty much constantly pouring in when it's daytime on that side of the planet. And even after noon, 1 o'clock, 2 o'clock, 3 o'clock, depending on what season you're in, the sun's still pretty high in the sky. And so the sun basically has a constant heating effect on the planet the entire time the sun is in the sky, and so there's an accumulation. We're getting the most rays indeed at noontime, and that technically, all things being equal cloud-wise, that should be the time when it would be easiest to get a sunburn per se. However, you can still get a sunburn at 1 o'clock, at 2 o'clock, at 3 o'clock in the afternoon, because the sun's still pumping in energy. And until the sun gets far enough towards the horizon that it's not putting in as much energy as we are losing, or as is dissipating in the atmosphere, it's going to continue to warm, and that's why we see it continue to get warmer, well past noon, all other things being equal in terms of cloud cover.
Okay. I'm going to go step past that one a little bit, and I'm going to go up to probably some people that would consider some of these things to be conspiracies, but you were talking earlier about the Uyin factor, and, well, I'm calling it the Uyin factor. I don't know if that's what you call it, but how is this, if there is any play on this? I'm just going to throw out 3 countries, basically, or 3 countries in one location. Yellowstone, because we see that there's some extra activity going on there. Iceland, with the volcano that's been erupting up there. Japan, who's been getting hit by all these cyclones and other storms and other things, and you are much more familiar with that because you include them in your shows every day. And Chile, just to name 3 in particular, countries plus Yellowstone. What do you have to share with us about those places?
Well, absolutely. The Iceland volcano, as I mentioned, it had a couple of big low-pressure systems basically just racing right over top of it. It's fairly clear that there was a coupling mechanism at work there. And a lot of where those 2 fields of science I mentioned earlier meet in the middle has to do with electric coupling, basically mechanisms for electric and magnetic influence from the highest levels of the atmosphere down through the ground. And we've seen that in Japan as well. We've seen it more a little off the coast of Chile near Easter Island and the southeast Pacific Ridge. We've seen it more there than we have in other places. And those would definitely be, spot-on examples of this. Just yesterday, in the past few days, we've had earthquakes in Hawaii, and then in the Atlantic, right on the mid-Atlantic ridge. And if you look now at the mid-Atlantic ridge, there's 2 massive lows just sort of playing off one another. One of them is Tropical Storm Faye. And the latest tropical storm on the planet actually formed last night, and all the models show it heading right at the above-average earthquake that we had in Hawaii, plus the erupting volcano that is there at Hawaii. They're all on this one line where these storms are heading. Yellowstone is a little different, and what I'm going to say here is probably different than what many other people are saying. Yellowstone is one of, in my opinion, the least worrisome places on the planet. Ever since I started watching this stuff, I have seen an uptick in seismic activity and geyser activity every couple of months, every 8 to 10 months or so. And every 8 to 10 months or so, people begin to get worried, during these times that, there's a little bit of an uptick at Yellowstone. Is it about to go off? Well, the issue is that you can find these upticks literally every couple of months at Yellowstone, going back as far as we have records. And what it really shows is that Yellowstone is releasing its pressure, which should be considered a good thing. I would imagine that if I went 4 or 5 years without seeing one of these upticks, I would begin to wonder where that energy is building up, that energy that we usually see in little earthquake swarms and slightly increased geyser activity. I would really start to worry about where that's going. But as of now, it's doing exactly what it should be doing, what it needs to be doing to avoid a supervolcano eruption. Now, the latest fervor, the one that's happening right now and continuing right now, and has been pretty much going on for a few months, it was a completely normal seismic and geyser uptick at Yellowstone, but there are two things that happened at the exact same time that are really sort of fueling a lot of the fears about Yellowstone. First of all, in the summertime, we have a road or two melt around Yellowstone every single summer. It always happens. There is a lot of geothermal heating. They have a lot of blacktop there, and it just gets really hot, and roads begin to melt a little bit. This is just something we see every year. This year it just happened to happen at the exact same time as the quake and seismic uptick. Furthermore, because of the exact timing of the uptick this year, it happened during the seasonal animal migration. So even though these animal migrations happen at the same time every year, this year it looked as though they were fleeing Yellowstone at the exact time of the uptick. And so we had pretty much a perfect storm of things going on that would make people point to Yellowstone. And if you had not been following it for years and years, you might say, wow, it really looks like Yellowstone is getting ready to pop. But to be perfectly honest, the caldera near where you are and the caldera in California, I believe actually present much larger concerns. For example, the one in California, we don't see this sort of activity all the time. It's much more quiet and much more dormant of a supervolcano. But we've seen some magma movement. We've seen small, very intense earthquake swarms, and not usual activity for some of these locations. I can't as much speak to the one where you are, but yeah, there's volcanic activity pretty much on the rise all over the planet. It just so happens that Yellowstone seems to be taking its time and doing its long-term cycle right now.
I'm glad you actually answered it the way you did, because I know there's quite a lot of people that are basically very nervous about Yellowstone, and for me, you made perfect sense.
Yeah, it's actually been a bit of a sore point for us, because we've made obviously friends here and there online, and some of these people online have basically made their content Yellowstone focused lately, and it really is not something I can get behind. There have been a couple of people who have been upset with me for this. I see these things happening all over the world. The world is not getting better by any stretch of the imagination. But I also don't see anything abnormal at Yellowstone. And, that's really the last thing that a lot of these folks delivering some of this content online want to hear, because it has been a very, very successful click getter, if you will, online for a while.
Well, yeah. It's something, and I'm going to deviate just a little bit. This is something that, what you're just talking about. What I've talked about for years is that when people pull details and make the detail the biggest thing that's going on, it tends to scare people, and it does other things with people, because like you're saying, if you put the whole picture together, if you know the migrational habits, if you know that every year that a road will actually, sizzle in Yellowstone, and even to add this, before the internet became what it is today, I used to watch a lot of PBS TV well, kind of like the Discovery Channel. I don't know if it was back then. And no, it was Nova. And Nova was talking about, this was over, well, not quite 20 years ago, but between 15 and 20 years ago. They were talking about how, this was back in the 1990s, how Yellowstone had actually risen 10 inches. And now that was almost 20 years ago, and Yellowstone is still here. So it's kind of building the fear factor, and people want something to look at and to watch, and ooh, this is going to happen. It's almost like you just want a disaster to happen. So, ooh, look,
Well, not to immediately sort of jump ship to the other side, but those folks may have some things to clamor about that are actually real here very soon. There are a couple things happening on this planet right now that haven't happened for at least a couple hundred years, and some other ones which may not have happened for thousands or tens of thousands of years, and it all seems to be culminating right now and appears to continue over the next few decades. And so those folks may indeed have something to clamor about. I'm just pretty sure it's not going to be Yellowstone.
Well, I'm not saying that I'm discounting what they're saying. It's just that if you focus on one thing,
right,
that one detail, it can be blown out of proportion. I guess that's the best way I'm going to put it. But since you did enter into that, let me see within the next couple of minutes that we have, what do you have, or do you have anything on what's been going on, talking about these blood moons and the lunar eclipses, one we just had just last week, actually?
Well, there was a lot of clamoring about that, and the color really is just sort of a function of, what our atmosphere does to light.
Yeah.
In terms of the lunar eclipse we just had, and, we're going to have a solar eclipse on October 23rd that's visible for pretty much just the United States and Canada. It will only be a partial solar eclipse. Most people don't know that there are 3 to 5 eclipses on average visible every single year, based on how the moon oscillates up and down on basically the plane around which Earth orbits the sun. We get an eclipse every couple of months or every couple of weeks sometimes, and people have tried to correlate this with seismic activity, volcanoes, storm activity. I think that the people who do long-range weather forecasting and use the sun and the moon probably have a little bit better grasp on how it handles with the weather. But we've seen eclipses that appear to be highly correlated with earthquake activity. And then we've seen, 3 eclipses in a row have virtually no correlation whatsoever with anything significant on the planet. So it's really, really tough to say. The blood moon thing, it's just like it's like a harvest moon or a blue moon. Sometimes these things happen. If it was 500 years ago, we might ascribe a very different significance to it. But at this time, just based on the observations, and it's really tough to put much more significance to it, other than it was really fun to watch that blood moon eclipse, because as it was happening, as the moon was getting covered up in the shadow of the Earth, the red color wasn't there. It was just dark black. And then as soon as the eclipse became full, this red hue just appeared on the moon and kind of lingered there, and it was really quite beautiful to watch.
Mm-hmm. Yeah, I was watching it down here.
Significance and stuff like that, I'm not really sure what significance it has for some of the events that we talk about on a daily basis.
Yeah. Well, we're going to have to unfortunately take one more break, and we'll be right back with Ben Davidson of Suspicious Observers. So stay tuned. We'll be right back.
Hello, welcome to K-Wave 6 Radio with Kirk Spencer. My name is Troy Matheson. I am a polymath and adventurer in arts and sciences, currently working with good people at newearthnation.org. I highly encourage you to check out that website. We're doing incredible things there. Thank you.
Hi, this is Amy Young of JSJ Phone. We are providers of junior iPhone, iPad, iPod, also Samsung, Sony, Nokia parts and accessories at very good quality and low prices. We sell to individuals, and companies have 3 to 5 days delivery time by DHL or UPS. We do delivery in 24 hours after payment confirmed. For more information, see our website www.jsjphone.com www.jsjphone.com. Contact me, Amy Young, mailbox emy@jsjphone.com or by phone 0086 134 1869635, by Skype emy.yang2012.
Hi, this is Richard Steinitz. I'm the author of Murder Over the Border, an Israeli detective novel, and Kaplan's Quest, a historical novel with an Israeli connection. I hope you like the books. You can follow me on Twitter, on Facebook, and even contact me by email on richard.steinitz@gmail.com. And I've enjoyed being here on K-Wave 6 Radio with Kirk.
Hello and welcome back. Again, my guest is Ben Davidson of Suspicious Observers. While on the break, Ben and I were talking a little bit, and, well, we do that all the time. But at any rate, we're going to talk about, or Ben's actually going to talk about, climate changes and climate changes from our solar system's point of view. So, microphone is all yours, Ben.
Excellent. Well, there's been an update to the solar system shift, I call it, since the last time we spoke, last time I came on the show. As of the last time we came on the show, we had definitive proof that climate change, in terms of things changing in the atmosphere and energetically, climate change was more significant on the Sun, Venus, Mars, Jupiter, and Saturn than it was here on Earth. If I'll quickly run through it, the Sun's highest storm or sunspot activity of the last 400 years occurred just a few decades ago, and at this point it's now weakening, the Sun is, faster than at any point we have in the geological or ice core record for the last 9,000 years. Venus's fastest winds have increased 33%. That number is about 3% here on Earth.
Wow.
Mars was warming faster than Earth was warming, and if you need a quick little primer into what Earth's temperature is actually doing, do not listen to Leonardo DiCaprio or the news. Go straight to the source, the International Panel on Climate Change, or the IPCC. They're the UN's governing body. And just Google something like IPCC admits no global warming. While there are parts of the planet that do continue to warm, the planet as a whole has actually cooled the last couple of years, and there has been no significant global warming for 18 or 19 years. And since that time hit, Mars has been cooling faster than Earth has been cooling as well. Jupiter, the big red spot, is dying. Little Red Jr. was born and is growing quickly. They also lost an entire planetary cloud stripe, and the radio emission of the planet Jupiter has changed. There is a 30-year Saturn storm. It happens every 30 years, like clockwork, on the dot, lasts for a certain amount of time, and then goes away. Except that it just arrived 10 years early, was twice as big as they expected it to be, and lasted way too long. This would be like a Category 6 hurricane hitting the east coast of the United States on January 1st, when it's not supposed to hit. and lasting through the summer.
Jeez.
But we just, this would be like, the changes on Venus would be like 350 mile an hour tornadoes, hurricanes with 300 mile per hour winds. It's just not the kind of thing you ever want to see here on Earth. And the other planets are showing these changes at the exact same time that the Earth and Sun are changing. And a question I've gotten a few times is, well, how is our pollution getting out to Jupiter and Saturn? Which I'll have to chuckle at. I think somebody could be that programmed to think that it was all about pollution. But since the last time we talked, when the last time we spoke, Uranus, whether or not they were having worse climate change, was sort of up in the air. We weren't positive. For the first time in the history of viewing Uranus from Earth-orbiting satellites and with our telescopes, the auroras were strong enough, or basically their version of the northern lights, were strong enough to be seen quite prominently. And so we're saying, well, that's kind of new, but we can't really just look at that and say there's climate change. Well, just about 5 or 6 weeks ago, we learned that the storm systems on Uranus are intensifying as well. We don't have a quantitative element to that, but they look bigger, and according to NASA and the ESA, they are getting stronger. So we now have pretty definitive proof that Earth is one of the least changing bodies in the entire solar system, but that the solar system itself is going through a bit of a shift, and it's probably due to these things happening on the sun, which only happen every couple of 100 years, and that's the sun exiting a grand maximum, which we were in from about 1930 to the late 1990s, aka the time of global warming. And since that global warming stopped and we have what's known as the global warming pause, the sun is on its fastest decline of activity in the last 9,000 years. The last time we exited grand maximum and entered grand minimum, which it appears we're about to do now, we had the little ice age here on the planet Earth. There was famines, droughts. When there wasn't a drought, there was terrible storms, there was large volcano eruptions, many more earthquakes being reported. Basically all that crazy stuff from our past that made our ancestors blame everything on gods because it was just so unlike anything they had ever seen before, coupled with their slightly different take on the universe. But that's sort of happening again now. Since about the 1700s, I'm going to say, this has been one calm planet. Now, I know it doesn't seem very calm, because the fact that we have volcanoes, we have earthquakes, we have tsunamis, we have tornadoes, hurricanes, and bad weather. But by comparison, the planet has been extremely calm during this time. And that's just sort of a little stroke of luck. Because it's about to end in all likelihood, and we're going to go back to that time where we see more earthquakes, more volcanoes, stronger storms, punctuating longer and deeper droughts. And it's going to be very, very hard to look around the solar system, to look at the sun, and not see this coming. It's very, very helpful to look back to what happened during the last grand minimum on our star, and see that we could be in for some pretty rough stuff. And at this point we're still in a phase of change right now that I call climate extremes. This is why it'll be 10 degrees warmer than it should be for your time of year, and then you'll get some bad storms roll through, and then it'll be 10 to 15 degrees colder than it should be for that time of year in your area. What's happening is, as the sun is losing steam, it seems that the planets are taking that energy and doing some interesting stuff with it, or perhaps they're interacting more with galactic energy in the form of cosmic rays. Here on the planet Earth, it's manifesting as higher high pressure and lower low pressure. Now what that means is that the actual center of the tropical storms will be stronger. It means that the tornado and lightning production in between high and low pressure systems will be stronger, even if it's not necessarily more often. When it happens, they'll be stronger. And that's because you have higher high pressure crashing into lower low pressure, and basically the way that these convergence zones work, where you have these tornadoes and these bad thunderstorms, especially in the United States, it's where you have warm, moist air running up one side of a pressure cell, and it's being met with cooler, drier air around from the other side of the pressure cell. And where they collide in the middle, they have to equalize, so to speak. They have to equalize their temperature, their pressure, their moisture content, and their electric potential. And as that happens, we get the terrible storms below. Well, as the high pressure and the low pressure are diverging, so to speak, or the highs are getting higher and the lows are getting lower, it's pulling up more air from the south that's hotter and that has more moisture. And the other side of the system is reaching further up north towards the pole and grabbing cooler, brisker, crisper air. And it's creating greater changes in the middle, and that's what basically drives these storms. And because of what I just said as well, that's why it seems like it's a little hotter than it should be. You get worse storms than you're expecting, and then it's a little cooler than it should be. And that's the type of thing that we should see during these climate extremes events, as the sun has not yet entered another grand minimum. But it really does appear that that's on our doorstep. This latest solar sunspot maximum, or what should have been a solar sunspot maximum, should probably be called a sunspot medium. And it's really looked like it's been sputtering a bit, just like it did before the last grand minimum. And so all the signals are there. There are now many, many solar scientists and even some climatologists coming around to this line of thinking. And many of them put the actual lowest point or the beginning of the charge of cold around 2020 to 2030 would be when we're really kind of in the throes of this. Now, the thing with a little ice age or a mini ice age is it's not like there's glaciers everywhere. This isn't the type of thing that froze a woolly mammoth with grass still being chewed in its mouth. This is the kind of thing that caused millions of people to suffer famine in India, in Europe, in parts of Africa. It was really well documented back then as well. And this is when, you have times for these natural bugs on the planet. I don't mean bugs like insects. I mean stuff that's in the soil. I mean, a lot of people don't know that anthrax is in the soil, and that every year we discover some squirrels with the bubonic plague running around the United States. There are just these things that are there, and they're naturally there. And during these times, they seem to express themselves a little bit more. Now, there's something else I want to end with before I go that's sort of adding to this. Now, while we can look back to the last grand minimum 400 years ago and know that we'll have some more earthquakes, volcanoes, and we'll have some more drought punctuated by flooding, and there should be famine and probably some proliferation of disease, but most of all, it should be cold. There's something happening right now that was not happening 400 years ago, and that's that our magnetosphere is weakening. And this is happening as the poles of the planet appear to be shifting as well. Now, the poles of the planet, the magnetic poles, they tend to meander around the polar regions a fair bit, given a couple thousand years' time. But normally as they do so, we notice no real change in the strength of the magnetosphere. So, for example, some of your viewers might know that the pole is now racing from Canada across the Arctic Ocean towards Siberia.
Right.
Well, a couple thousand years ago, it was over north of Norway, and then it began racing towards Canada, and all of a sudden it just stopped. Well, during that polar movement, there was no real evidence of any kind of change in our magnetosphere. However, during this latest polar movement, the magnetosphere is weakened 15 to 20%. And all indications are that that is continuing, according to the European Space Agency, and speeding up, weakening faster and faster. As this happens, we're going to be subject to, it'll be easier for a solar event to trigger an earthquake, a typhoon, a volcano, or a power grid collapse. It'll be easier for cosmic rays to come in and create the cloud condensation nuclei around which these massive storms form, and around the type of clouds that perfectly reflect light and don't let it get to the surface and heat us up. The fact that we have this thing happening on the sun now, we're probably going into grand minimum, was already going to have an effect on our planet. But if these magnetic changes continue, and it doesn't take a full polar flip in order for these things to have an effect. They're already having an effect. But since we're also getting these changes in Earth's magnetosphere, that, in all honesty, may end up becoming a full polar reversal on the planet, and then we've got a completely different story to talk about. But as long as this magnetic weakening continues, it's going to enhance all of these things in the climate extremes aspect and in the mini ice age aspect. Not to mention the fact that a weaker magnetosphere leaves us more vulnerable to all the other things that the sun does, like the triggering of earthquakes and volcanoes and storms and things like that. So it's kind of a hold on to your hats type of thing here. And it's not going to be the kind of thing where the world goes to heck in a handbasket overnight. But, it's going to be sort of a slow downward decline over the next few years and decades. And it's the kind of thing that we're capable of surviving, but you gotta stay positive. You gotta be aware of what's coming, and there's very, very simple preparations that can be done to help you, get through this sort of thing. It's not going to be the type of thing where 90% of the world dies. There's a lot of reasons for hope in this period. Maybe a better world will come out of it on the other side.
We do hope for that. With that, let me ask you two questions here. And one was something I was not really going to ask, but you kind of touched on it, so let me go there. You're talking about magnetic changes that are happening here on Earth, and you're also talking about how weather changes, per se, are being affected on our other sister planets of our solar system. And could that be that we have a stronger magnetic system than the other planets, and that because of our lessening magnetosphere, could that be the reason why we're starting to experience, as you are so often saying, climate changes? Because even down here the weather changes a lot. Compared to the 9 years ago that I moved here, the weather has been changing here, not dramatically, but it has been noticeably different.
Well, for example, we've got a bigger and stronger magnetic field than both Mars and Venus and certainly Mercury, but Jupiter's and Saturn's dwarf ours. So we're kind of looking at a wide range there. I think that we are seeing these changes because there's no way to stop the sun. There is no way to avoid what's happening throughout our entire solar system. In terms of why the Earth has so far not seen as bad a changes, and this is something that people do not want to hear, especially in our community. I see no excuse other than geoengineering and weather modification. Now, I need to make it clear, I'm not in favor of geoengineering and weather modification. Like I said, this has happened on Earth before. In fact, the last time it happened, people that looked like me crossed the Atlantic and made 13 colonies. Stuff gets done. It's not the end of the world. We can survive it, and we don't need to be playing God in the sky. And in truth, they probably don't understand what they're doing beyond the short-term effects. They are creating additional poisons by spraying either aluminum or sulfur oxides into the sky. And they may end up making it worse because you can't stop what's coming.
Yeah.
But that being said, Earth is the only planet that is not already experiencing terrible, terrible changes. I mean, we're experiencing changes, but they're nothing compared to the rest of the solar system.
Mm-hmm.
And the only real explanation is that we are trying to do something about it. And so when I mention this, and I also mention the fact that I don't think they need to be doing it, and I'm definitely not in favor of weather modification, and assuming that people can get that, a common question that is asked is, well, why wouldn't they explain this to us? why wouldn't they show us what they were doing? If this was true, why wouldn't they tell us, hey, you guys would be, there'd be millions of people dead now if we weren't doing this? Well, there's, and I'm sure you know this, there's a little thing about groups of people that, when they get together, they're not real smart.
Yeah.
I hate to quote Men in Black, but this was a brilliant quote from that movie. A person is smart, but people are dumb, dangerous, and you know it.
Yeah.
If they really explained to us, and if people really understood that the entire solar system was changing in a way that we cannot control, that we cannot stop, and that we are completely subject to the whims of the sun, and if they understood the breadth of changes on some of these other planets and what that would mean if they ever happened here, I think that there would be somewhat of a breakdown of society. There would be runs on banks, on grocery stores, on gas stations, runs on farms, runs on gun stores, and it would be a very, very dangerous time to be living anywhere. It would pretty much create anarchy. And in that type of situation, especially if it's global, anything that you would want to save gets destroyed anyway. It's the kind of thing where, for the sake of all of us, we can't know until everybody knows.
Yeah.
And it's about time for it to happen.
Yeah.
However, without, sort of ringing bells and raising alarms, there are little things we can do to sort of quietly get ourselves ready for them. And I know that my wife and I and literally millions of people around the world are already doing this now.
How about we can get you back at another time and you can talk more about that?
Absolutely.
Good. Before we go, though, I do want to ask you a question, one last question, at least one last at this moment. I don't know if I've told you in the past, but I am also a holistic therapist, and I've been doing this probably longer than anything else as far as one thing that I've been doing. In your knowledge and your experience, because you are a scientist as well, we're talking about climate changes, we're talking about energy changes, and we know that the human body is made up of, 70 to 80% water. It has its own bioelectric field. In other words, we're basically like a small planet within ourselves. Just putting it on a very simple basis. And we don't have time to get into that right now. But if you understand where I'm coming from, you as a listener, Ben already understands it. How is this sun activity and earth changes affecting humanity?
Well, there are, first of all, there are effects on the individual level and on the groups as a whole. We actually had an article published in New Dawn magazine a couple weeks ago about the effects of space weather on human health, and these range from things like seizures, heart attacks, strokes, to even depression, suicide, pregnancy rates, infant mortality rates, the ability of somebody to focus, whether or not they hear ringing in their ears. On a larger scale level, times of solar quiet tend to lead to proliferation of peace in society, whereas great wars and revolutions seem to be correlated more with times of high solar activity. Now, this doesn't mean that all of a sudden your world is going to get thrown into disarray because of something happening on the sun, especially because a lot of whether or not you are a positive or a negative person has a lot to do with this as well. Despite the fact that we are subject to this system, in the Earth and the sun and the solar system and all this other stuff, we also have a regulator between our ears, and it can allow us to handle a lot of these situations better than somebody who's not aware of the power that we actually have. Just think about the placebo effect. This is the best way I can think of to describe it. Everybody's heard of the placebo effect. and they just think it's some mundane little thing. But when you are under the placebo effect, there is no scientific reason, no biological or chemical reason for your body to be doing what it's doing. The only explanation for it doing what it's doing is that the electromagnetic waves produced by your thinking something are affecting and creating their own reality within the system you control. They've given people sugar pills, and they've acted in their bodies the same way a powerful chemotherapy drug would act, showing that just this person's belief and their imagining, envisioning that they're going to be healthy and happy helps manifest that. People talk about, they can make these frequencies that, really screw with your body. Well, you know about them. If you feel like perhaps you would ever be underneath, or under the influence of one of those frequencies, tell your brain it's helpful. Use it, and you will begin to feel better. I was so skeptical of this. I thought this was utter nonsense when I first heard it. I'm a very, make your observations, take your data, be as logical as possible. I'm that kind of scientist guy, but there is no denying the power of our own brains over the system that it controls. And, our environment, especially our electromagnetic environment, is going to play some role in how our bodies are affected by all this, but at the same time, your ability to take care of your own mental and even physical well-being is no different than your ability to go out to the store and prep for what's coming in the weather. It's just that easy.
Indeed. Ben, we've got a lot to talk about, and like I said to you once over while we were off air, we need more than 2 hours even just to do an interview with you. But you've agreed to come back, and you can make that as soon as you want to, and we'll do another show. We can do as many as you want. You're welcome to come back anytime you want. Just let me know. With that, I'm going to say thank you very much for being here, Ben, and for our listeners, I want to remind you that we are on iTunes, Stitcher, Podcast.com, RSS feed, and on YouTube. You can find the links directly to any one of these media players on our homepage, or landing page if you prefer, which is www.kwave6radio.tk. All media players can be played on your smartphones as well as your computer, so you can listen to us while you're on the go. All episodes here are always free. And with that, we ask that you also support our advertisers. And if you miss the advertisings, please go to our advertisers page on our website. You can subscribe to each media player that you have chosen, and also ask that you that you will follow us on the website and our blog, just to get the information directly to your email. And if you have any suggestions and or comments about the show, or even you want to talk to Ben or ask him questions for next time he comes on, you can send us that information at info@kwave6radio.tk. With that, Ben, any last words?
No, just eyes open, no fear. Be safe, everyone.
I love hearing that every day. Thank you, Ben, for being here. Thank you, everyone, for being here, and we'll see you again soon. Bye-bye for now.
Thank you for being part of our audience. For more information about K-Wave6 Radio and the services we offer, go to www.kwave6radio.tk. Have a wonderful day.